Okay, so thank you everyone for joining us today. I have had a chance to meet a few of you throughout the last couple of days. I'm Fernando Macias. I work for VMware. My focus has been networking for quite some time. My exposure to the physical security access control industry was through Cisco. I worked for Cisco for many years. I got to meet Ray and a few of you along the way. And I only did that for a couple years. Then I moved away. I went back to do other things. Now I focus more on virtualization, data center, more on the IT side. So bear with me. I know a little bit about your industry, but Ray wanted to really give a little more of what this whole virtualization is about. It's a different world that you may not be using every day, but keep that in mind, right? It's there, it's real. There's a lot of benefits in doing that. Who has heard about VMware or is using VMware today? Oh, okay, I like that, great. So VMware has been around, what, 20 plus years now? And if you remember, the first days was virtualize your server. And what did that mean? Well, we're gonna cover some of those areas. I'm thinking about covering server virtualization. What does that mean? We have one server, we can have multiple VMs, virtual machines. Talk about hyper-converged infrastructure, ACI, you all heard the term. It's really just another way to virtualize more of the elements you have in your data center. We'll touch on software-defined infrastructure. Has anybody heard about SDDC, software-defined data center? Awesome, great, great. I live that every day. I talk to customers, I focus mostly on large enterprise customers. There's a lot of benefit in doing that. So we'll talk about that virtual networking. It's like, what do you mean? We have layer 2, layer 3, switching, routing, all these components. Let's do it in software. And again, it's been very successful that way. We'll touch a little bit on cloud. I'm sure you hear about cloud all the time. We'll see how you can see some of the benefits on cloud. You can realize those on-premise as well if you want. So that's my plan. Of course, let's keep it active. You know, I welcome your feedback. I think I can learn more from you than you can learn from me on that space. So please, okay? So let's start with this. Let's go touch a little bit on history and why this became so popular. So what is virtualization? You can run multiple operating systems and applications on the same server at the same time. If you were VMware and you went to talk to a customer back then, all these applications, you can put them on one server. It's like, are you crazy? Why would I ever do that? So there was a reluctance to do that. Like, it's not gonna work. Of course, we know the reality really worked very well. You can virtualize servers. You can put multiple, let's say, Windows operating systems, and they can all run just fine, right? Now, you can also run it all the way to your laptop. If you have a laptop, you can run VMware in that and virtualize that. So if you want to have a Windows VM running a Linux operating system, why not? You're sharing that CPU, that memory, to make better use of those resources. So same concept applies here. The benefits are obvious, right? Instead of dedicating one server for one application, now I can throw 20 in there, depending on the memory, CPU, et cetera. I think that's pretty cool. So fast forward here, nobody questions that, right? It's a reality, it works. If you're more visually inclined, it would look something like this. So you have one server. You would dedicate a whole server for a whole application. Let's say your analytics application, you would put the Windows, I'm gonna go back to Windows, but it could be any operating system. That whole server would be dedicated for that. Pretty wasteful when you compare it to using this, right? Now you can have multiple operating systems if you want, multiple applications on that server. So who's using VMware for this purpose, server virtualization? Excellent, great, awesome. I'm glad to hear that. So the benefits, I think we all understand that. Some of the properties for these VMs, virtual machines we call them. So every little piece of that server that I allocated, it's a VM. I can partition that. I can run multiple operating systems on that server, great. I can divide the resources. That is big. It's a lot going on in there because I have that CPU and that memory. I can split it for each VM as they need the resources. In fact, throughout the years, VMware got so good at doing that you may hear, oh, I have a bare metal server, a server that doesn't have a hypervisor, it's not virtualized. The performance is better now on a hypervisor in a virtualized environment because they're able to tweak and dedicate those resources so well. So it's good to see that. Isolation. What if I have this VM that is affected? We have some attack, this has been compromised. That VM shouldn't affect the other VMs. It can crash, the blue screen of death, we used to call it on Windows. Great, right? You can crash all day, but the rest of the VMs are okay. So that isolation is very important. Encapsulation, that whole VM, I can save it into a single file. So that's pretty nice, right? Because now I can move that file. I can copy it for backup if I wanted to. Maybe I can do a snapshot. You may have seen snapshots. Let's say I have a new version, I need to apply a patch. I'm gonna run a snapshot just in case, right? Things go bad, I can just go back and replace that snapshot and life goes on. I didn't miss a bit. How about vMotion? The idea is to move a VM from here to there. I can do it without downtime. I can just say vMotion or migrate from here to there. And that there could be the cloud. If I want to go to a cloud location, great. That VM continues to run. No downtime, I can do that. So all those things become very important. Gives us, of course, a lot of flexibility, a lot of things I couldn't do before with a physical server, right? I just couldn't grab a physical server and magically make it appear there with no downtime. Now we can do that. Hardware independence, so I think I just touched on this. I can just migrate a VM to a different physical server. Okay? So I hope that I made it very quick. I just wanted to move on, server virtualization. You guys get it? Let's move on, unless you have any questions or comments. Okay. I'm sure we all have heard the HCI, Hyper-converged Infrastructure. I assume you guys have. It's real, right? Why? Because the same benefits we saw in virtualization at the operating system level, let's add more to that. Let's see what that looks like. I think I clicked too many times. The way we have been managing this, I think we all live this. You have your own servers or blade servers. I dedicate all this hardware, my cabinets and all that. Maybe there was an external storage. I would dedicate another storage environment just for that. And of course, the networking would be also another component, and security. And you add all of this, you have all these silos. Oh, by the way, I need to have a networking VLAN provision. I have to talk to the networking team. Oh, how about my stores? I need to have more stores. I'm running out of space, which always happens. Now I have to go talk to the storage team. The idea here, if we combine all of this into one single environment where we can manage it with the single common tools, all those things go away, right? And we're going to expand this into the networking. We can virtualize the network. So the idea is one single environment can provide all the resources you need. All for your applications, remember? It's all about the applications. We were talking about that earlier. We do all these for the applications. The application can be an analytics, access control, video surveillance. It doesn't matter. They have to be running. So HCI gives us a new model. I'm going to touch on this image here in a little while, but if we start from the bottom, I don't know if you can see in the back, built on industry standard servers and switches. We don't want to force you on any specific brand, right? If you like HP, Lenovo, Dell, it doesn't matter. We combine server, the virtualization we were just talking about, and storage. We're going to add networking to that and a unified management. Again, I'm going to touch on this later, so I'm going to move on. 3 products that we focus on these from VMware. VMware vSphere is the ESXi hypervisor you already know. That's one of them. vSAN, in our case, our hyper-converged infrastructure is vSAN. We're combining the storage into the same hypervisor environment. From the networking and security, we have NSX. Has anybody heard about NSX? Excellent. Beautiful. I'm glad. That's my main focus, by the way. That's NSX. And it's been a super incredible success. A little bit of history on that. What's happening to my voice? I have water, so thank you. VMware acquired Nicira 2012 for $1.2 billion. Martin Casado at Stanford with their OpenFlow project.
1.26.
Oh, Mike, sorry.
That 6 is what? It is 600 million of them? At least 600.
relevant.
Just for the recording, 1.26 billion. Thank you, Mike. And that brought out a lot of these technologies that became NSX today. Just for reference, last year we sold 1.2 billion. I don't know if there was 1.26, but certainly it's being a very dramatic approval of NSX and adoption. So it's been great. We'll touch on that a little bit more. So HCI, we talked about earlier, having a server where we combine multiple VMs. Great. We're going to take it a step further and say, well, all that CPU and storage that we have now, why don't we combine it all into one? We have the same management structure, ESXi, that we manage with our vCenter. Now you're making use of that storage from all those different servers. SSD, solid state drives, right? SSD down here. So that's the idea. And again, it doesn't matter what brand of service you have, the benefits are there. I keep saying that, but that's very important. Same thing with NSX. We don't force you to go to a Cisco network or Juniper Arista. It doesn't matter. You should have the option to do that. So that's HCI. There's a lot more in here, right? Because I need to say, well, how much data do I really need? And I think it's a $64,000 question all the time. How much data do I need first, right? We need to make sure you have the right sizing, et cetera, et cetera. With ACI, the good news, if you just run out of storage here, you just add more as you grow. So much easier to grow than the traditional way to do storage. So the idea here, we have more flexibility. We can add more. Simplicity, I can manage that from the single environment. I don't have to have silos that we talked about earlier. On-demand grow. I can grow as I need. I want to touch on this. The architecture adopts cloud principles and economics. What does that mean? You have seen that, and we're going to see that this afternoon, more about cloud, what are the NIST definition, et cetera. But some of those would be elasticity. I need more, the system this should be ready for me, right? Black Friday is coming, I better have the resources ready to go. Pay as you go. I need more, I pay more. Maybe another one, the way I deploy that, I should be able to do it as a user. I should go to a portal and say, I want these resources, magic happens and they get provision for me. So that's what you start thinking about that. AWS, Azure, or Google, GCP, they have been doing that for quite some time, right? Has anybody used any of them, the main public providers? Excellent, excellent. And the way it happens, I log in with my AWS account, for instance, the same account that I use for shopping, and I have 1 full year to have resources in AWS. I can create my cloud, my VPCs, add security, all of that, without telling anybody that I need that. Of course, I need my credit card because you pay as you go. But that's a reality, right? So when we want to do cloud-like environments, you always associate that the public cloud, you can do all that on-premise. You heard the term private cloud. Now I can do all that. So the benefits that we talked about cloud, you can realize those on-premise, on a private cloud. Okay, it is based on software. There's a lot in this sentence. Think about it, you don't call AWS and say, oh, I'm gonna need 3 servers with 10 gig interfaces and 1 terabyte of data, right? Like, you don't call anybody, you just do it on your own. All that is done in software. That's gonna be the key. I come from a networking hardware background, so it's, once you realize that you can do so much more with software, the hardware has to be there, don't get me wrong, you need to have a very reliable, a very good network, right? Everything has to be there. But you start to do a lot more in software. That's the whole idea of this cloud environment. So in the past, we used to buy a lot of hardware, right? We used to function based on hardware. We all used to hear, oh, this box has an ASIC, an integrated microchip that is 10 times better. Wow, great, right? But they were purpose-built ASICs that they have to be updated, right? So the features, you used to tie them to a hardware device. That's what hardware vendors wanted to do that for obvious reasons. Of course, to upgrade that is pretty challenging, right? It's not, I don't have the option to say, oh, there's a new patch for my Xbox here. No, you have to get it out, put a new one. And the hardware vendor may come the next year. It's like, oh, we have a new version or a new flavor of this box. 3 years later, oh, that's end of sale. Sorry, you have to upgrade, right? I think we all have seen that along the way. That's the way it's been done, right? That's when we tie our services into hardware. Of course, they're harder to operate, maintain. From the Cisco point of view, you still hear CLI, command line. I'm sure you have heard that. Like, I still have to go and touch every box and log in and configure my IP addresses and all that. Yes, and you'll get your Cisco certification for doing that. Okay, so how about if we do it in software? If we have a fully virtualized data center, not only from the server hypervisor, but the storage, the networking, the security, we can port this anywhere. So today I'm running on my ESXi, my private data center. Tomorrow I can go to AWS. Or the day after I can come back, or I can expand to another data center. You're not locked to hardware. You can realize all these benefits. You're virtualized. Common management tools for everything. I don't have to have these silos, right? And I don't have to call all these teams that take forever to deploy. Some of my customers, we go talk to them, it's like, oh, this line of business needs a new application. Great. You better wait because it's going to take several weeks for the networking team and the security team and the storage. And I don't have 8 weeks to wait, right? I can go to AWS, give them my credit card, and I'm up and running in 10 minutes if I want. Yes?
Quick question with that. So you're saying no hardware lock-in. So if you're doing hyper-converged infrastructure, hardware is involved in that.
Yes.
So what if that hardware goes, if that hardware goes end of life 3 or 4 years from now, you have to replace it.
Yeah.
Right?
Yeah.
You can move it to somebody else if you want to not use it anymore.
Right.
If you're going to use that hardware goes obsolete at some point.
Yes. We still need the hardware, right? You still depend on that hardware, but maybe you're not forced to replace that hardware because the vendor introduced new features to that. I'll give you an example. Nothing against this, but Cisco has their ACI. They are on the 4th release at least. They have come and say, now this microchip, this ASIC is going to give you the flexibility you need. You need to upgrade. We have customers that say, no, my 6500, my Nexus switches, they're a little older, but I don't have any problems with bandwidth, right? That functionality, you use the network as capacity. Then you can do all the functionality in this overlay. And I'll touch on this again later.
If you need more capacity or you need more things, then you just add to it.
Exactly.
Or just at that time from infrastructure.
And you're not tied to a specific brand, a specific hardware resource. That's the idea.
So one thing, almost all vendors have gone to merchant grade silicon. Everybody's using Broadcom, so it almost doesn't matter.
Yeah.
Right. Good point. It shouldn't matter, right? That's the idea. It shouldn't matter if your server is Dell today or whatever flavor you want later on. Yep.
He couldn't bring himself.
Exactly. Yeah. And not only that, not only you can go to another server vendor, but you can go to the cloud. In the case of AWS, we have a service called VMware Cloud on AWS. That means we're sitting on AWS. We're the only vendor that does that. You have ESXi servers running on AWS. It's like, I already know how to use VMware here. I have my vCenter. I know how to manage that. That data center out there in AWS in the cloud, it just shows up as another little cluster here. Yeah. So yeah, a lot of benefit when we do that. Software updates, I can bring new features all the time. I don't know if you may have heard a lot about development teams. The development teams, they are releasing features all the time. I mean, look at your phone. You have a new application that, oh, there's a new button there. It wasn't there yesterday. You don't care, right? In the old days when we used to develop applications, they were huge. A monolithic application that took months to release, like, whoa, some of us lined up for Windows 95, I think it was, when it was like, oh, it's a big deal, right? Yeah, it's been a while. But now these updates happen all the time. You hear development teams, they release 20, 30 updates in a day. We don't care, right? So we're doing it this way. So think about all the benefits you can start having. It's from the physical security, the access control, but there's many other areas where virtualization can help. Okay, so back to this. Traditional three-tier architecture. We had our servers and blades. We had our storage. We had the networking hardware. ACI allows us to combine all of this, and we saw this earlier, but I wanted to show it again, because now you start to have the same management tool, the same vCenter that you have, that you love or hate, it doesn't matter. That's the one you're going to use. You can do all these things. Allows you to grow, you have the flexibility, etc. So that's HCI. I mean, there's a lot of vendors that provide that functionality, which is one of them. But the idea is to virtualize and start realizing the benefits of HCI. Ours is VMware vSAN. I talked about this. And no surprise here, right? We're talking about combining the storage into the hypervisor. So these are ESXi servers. I'm going to add vSAN, and I have all the benefits of HCI. I can manage it, I can add more, etc. Some of those benefits, when we talk about cost, in the old days, if you wanted to buy storage, that was a 64,000, how many, is that 64,000? It used to be, doesn't sound like much. The 64,000.
That's right, that was the game show.
The 64,000.6 question.
My slow brain has not done the math. That 0.6 is $60 million. Just
Gee, yeah, it counts.
Just change.
But anyway, back then, to understand how much you would need, it was very challenging, right? How much storage do I need today? Or how much will I need in 1 year? EMC would come and say, oh, you better buy these super big rack of everything, right? Because you don't want to run out of space. So you would buy a lot of storage. CapEx was very expensive at first, right? You had to buy a lot. Not only that, to add more, these are supposed to be steps, so it takes you a lot longer to scale, right? Not so easy to add more storage. With an ACI solution, you buy much less because you're adding that storage inside your hypervisor. If you need to add more, just throw another server with more data, and it's going to be shared across all your VMs. So very important to do that. When you're thinking about storage, I don't know how much I'm going to need a year or two from now. Fine, I can add as I go. So it makes it more predictable, easier to scale. So I wanted to add this here because you may have seen this also from your own customers that you deal with. The most important challenges in the next 12 years, this comes from 451 research. Let me focus on the first three. Respond faster to business need. There's a lot in that, but look at that. Almost everybody says, yeah, I need to do that because I don't have time to wait for all these silos and all these groups to deploy these resources that I need. That's important. Reduce cost, we all hear that, right? If I have more silos and more teams, it's going to cost me more, it's going to take longer. I want to reduce cost. And the last one, improve reliability and availability. For you guys, it's critical, right? You don't want those security systems to go down for a couple hours. No, they have to be up and running because a lot can happen in that casino at that time. We don't want that. So I'm going to focus on those. Of course, security is important. I'll cover a little more on security, but responding faster to the business needs is a reality. Hopefully, virtualization will be a tool to allow you to do that. Questions on ACI before we move on to network and security? Or comments? Yes, please. Oh.
So there's a lot of consultants in the room that maybe are doing HCI. When is it that within a security installation, whether it be enterprise, or when is it that that HCI system really takes over from a traditional SAN, from a traditional bank of servers?
I'd like someone to help with that.
Is it just in that enterprise space? Is it just in that high-end data center space? Is it 50 cameras? Is it 2 million cameras? I don't know.
Depends on the level of high availability.
Yeah.
Right?
No, or IT.
Yeah, there's two components to that. I think it's IT's decision for the most part. You know, they have to make that decision, but it's also, you know, what information are you pulling from the operational environment, right? And what for use? And if it's security alone, then it could be a blend of the IT department and security department defining how it's used in terms of. Right, and then if you're not in a GSOC environment and you're typically going to be in a supervisory decision of response, then you're probably going to go virtual because you don't want to have to deal with all the infrastructure.
To add to that, though, which Peter probably repeated, is culture.
Culture is a big one.
Culture of the IT.
Yeah.
So what's the organization? Are they hardware? Are they virtual?
Yeah, and it's usually to be honest with you, what I see more is a blend, right? So, on-premise and virtual, and they migrate over time, and it depends on their storage requirements and what they're doing on terms of storage. Cloud use in storage is a big key to, I think, in terms of that decision.
Michael?
What we see a lot of is whether it's attended. So we see a lot in HCI of sites that actually, they don't have somebody they monitoring constantly. So the ability for the VMs to fail over the same data set is critical. If somebody's not watching, you can't lose your video. And more importantly, if a site needs to actually access the recorded video, if you have a physical server and the physical server goes down, you're not getting that data back for review until that server comes back up, if it comes back up.
Yeah.
When I can migrate the VMs and share the same data store, now it's unattended, and whatever the timeline it takes to come back up, you can immediately access that video while migrating the operation of the VM to another box.
You get better
And
redundancy.
like these on managed services environment, they're already going virtual. They just say, I'm moving outside the parameter and I'm using someone that's defined for my model.
Yeah, but maybe to go back to the nature of your question and just full disclosure, I'm a pivot 3. I have a vested interest in the answer. So but when I was at VMware, so I think we missed the answering. When VMware was growing up, small medium enterprise was really the initial target, right? So your question about what size of business where hyper-converged infrastructure or virtualization makes sense for, well, VMware growing up serving the sub Fortune 2000, and because there was a resistance to virtualized tier 1 applications, right? So the big boys stayed out of the space. But as VMware matured, they pretty much dominate the small, medium, all the way up. But I would not say it's a size or maybe it's a maturity of an organization and less about the size of an organization. Is that a fair point? Yeah.
Sure. Right, and they're understanding about it, how to use it, how to maintain it, how to effectively implement it.
And how to control it. Because if they have no controls in place, they haven't reached the questions of controls on physical or cyber, then, you're probably going to leave it to someone else to figure out.
And I suppose you get on the road of being an integrator of the system and installer that's also comfortable doing it.
Yeah.
But I coming into the space and selling a technology into the surveillance industry, what I see out there, the impact, it's almost like there's still a real sweet spot, and because I'm kind of going to go backwards on my answer, it is a maturity thing, but virtualization, hyper-converged infrastructure has the ability to jump the less mature organization ahead of to a higher level.
Yeah.
So we see it, again, small, medium enterprise, large enterprise, equal benefit.
I'm going to expand on that a little bit. Culture, maturity. Yeah. We're all friends here. Now we can do more push-ups tonight and see.
Where the Seneca guy was in the room. We're dying for you to actually get in the hyper-converged space.
Great. So touching back on maturity, culture, just like Mike mentioned this, it's been a challenge for some groups that the ones that realize I can do this, I can have all these benefits, why not? We see the same thing on the network and security, which is funny because for me, coming from that space, I come to talk to customers. We tell the networking guys, oh, by the way, you can virtualize. You have this overlay, you can automate, you can do all these things. Like, why would I do that? My Cisco switches work just fine. So it's challenging. Yeah. So the companies that see the benefit and start realizing that they are more agile, they can compete better, the rest of the story, right? There's a lot of benefits. So let's touch on network and security. What can we do with this? Now that we virtualize the servers, we virtualize the storage, we have this common management infrastructure, We go back to the SDDC, Software Defined Data Center. I'm sure you heard SDN for the last 9 years, Software Defined Networking. A little bit. Who did something with that, something real?
Actually, so I was working with a couple of companies. We're actually still working with one, where we're taking traffic profiling off the camera. So you identify an access camera, identify a Panasonic camera.
Beautiful.
Getting the traffic profiling, you can actually provision the network port, the VLAN, the security domain, whatever you're going to put into the services, and it's completely automated. More importantly, when you disconnect it and you put a laptop in and try to penetrate it, you belong to an isolation VRF. You're nowhere.
Yes.
So there's I'm not saying 802.1x is not my favorite, but anybody who knows me knows it's not. I don't really care for it. So there needs to be a better software-defined way to do that. So
Beautiful example. And hopefully you have seen Darren's videos on YouTube. I was watching those yesterday. They're awesome. But
which videos?
I'll tell you later. But they're good. Moving on. Thank you, Darren. But yeah, software-defined networking allows you to do a lot of things that we couldn't do before. We're combining software. Now we're using all those features to do something with that. In our case, when we talk about SDDC, it's not only the networking that we're virtualizing. We're doing the whole stack, meaning VM. You want to deploy a whole environment with VMs? Of course we can do that. You want to add a firewall to that, a load balancer. All of that can be created in SDDC. When you look at this, you start looking at the hardware just as pooled compute is right here. These are just pool resources, right? I'm going to have my server rack. We know they can do virtualization of servers, storage. I'm going to do that on the same platform that I just had. It doesn't matter if it's on-premise or in the cloud, I can do all that. So then you start to see this. This is just like an overlay. Overlay up here. We're going to do a lot of fun things using this underlay. I'm throwing those terms. I imagine you heard them, but this is overlay. We don't care what the hardware is. We don't have to update it all the time. We're going to do a lot of fun things with that. So with NSX, we create this virtualization layer. We know this hypervisor that we love and rely on every day is going to give us those resources. We have the storage. It's already ACI. Why not? Now I can do a lot more with that. I can do my routing, my switching, my load balancing, my firewall in a distributed fashion. If each one of you is a server, I can distribute this NSX functionality to all of you. The moment you connect, now I can move VMs to every server. Micro-segmentation, I'll touch on that a little bit more. I can firewall each one of those VMs sitting on those servers. That is huge. Again, we'll cover more on the firewall part here. So by doing that, we start to realize all the benefits. You have all the VMs up here, this NSX platform. Now I start to maybe vMotion, secure. I can create as many as I want anytime. Full working environments running NSX. I'll give you an example from a customer. For them, it used to take 8 weeks to deploy one application. With NSX, it took us a little while to automate it, and we say, you're a developer. You need to work on the environment that was running last night. You, as a user, you go to the portal. You say, I want to have that environment deployed again because I want to do some testing, whatever it is. They are a security company. You can do that now. Before, it was just a very slow process. So we're talking about the cloud, the self-provisioning, the elasticity, and all that is there. They love it, right? So it gives you more benefits. You can compete better. You can provide resources, et cetera. So some of the benefits you can get from that. So this network hypervisor sees all those servers as pooled data center capacity. If you need more, you add more. Just plug it in, install the NSX drivers, you're up and running. You need more storage, plug it in, define that as part of your ACI, keep going, right? You have that elasticity once you virtualize. Now look at this. We have 3 applications. App 1 may have its own switching, its own routing, its own load balancer. The typical 3-tier application that we work on most of the time, my web servers, my app tier, and database. Meaning I go to a web server, google.com, I'm reaching the web tier. From there, they can launch a request to an application maybe, to request data from a database. But the idea is the web server should never talk directly to the database. Or you as a user should never talk to the database. right? So you start creating all those applications. App 1 can be completely different than 2 or 3 and all that. I put 3, but of course you can deploy a lot of different applications in that same environment. With the same benefits, we talked about that. Server virtualization, you can isolate, you can protect, you can migrate. All those benefits are still there. We're just adding the network and security to that. If you have been to one of our shows, or if you haven't, you can go to VMworld. You can watch every video, every session recorded from there, so there's a lot to see. You will see this, NSX everywhere. We keep talking about this. Everywhere means, how about your private data center? Why not, right? I want to go to the branch. I have my software-defined wide area network. I can extend those policies there to make them consistent. I can go to a public cloud. Why not, right? Today we can do with AWS, Azure, and like 4,000 other providers. Choose the one you like. Now you have that security, that networking that is consistent across those environments. VDIs, anybody doing something with virtual desktop? There you go, great. Virtual desktops are actually a very good use case for NSX because the way virtual desktop works, I go from my PC, I want my virtual desktop or a thin client, it doesn't matter, and my desktop, let's say my Windows environment is there for me. It lives in the data center, but I just have a screen view of that. The challenge with that, think about what we just did. We grab all those virtual desktops, all these VMs, throw them all the way in the data center. It's like, hang on, you just brought all those contractors and everybody, they're sitting there in my data center. Yeah, we have heard very heated discussions with, it's like, oh, this is a wonderful story, but now you just threw them all the way there to my data center. With NSX, you can segment them. You can create a micro-segmentation rule that says, even if you're sitting on the same VLAN, you'll never talk to that other VM, period. So. Yes.
Can NSX drive like an MPLS like VRF type of environment where it can do virtual routing to 40 down to the hardware?
No. NSX is focusing more on the overlay, right? We can do the switching and routing. We can create full network environments in software. We're independent of the hardware.
But it can provision that down.
No.
The clients I have want it micro-segmented with their own routing tables, their own VRFs, everything else below there.
Yes. I'm going to expand on that a little bit. We don't care because we're using VXLAN. That's a protocol that we're using. So it's not a VLAN. If you're not familiar with this, VXLAN, it's a tunnel protocol. That gives me, you're the source server, my destination server. VXLAN creates that connection between the two servers, regardless of where they are. Once I do that, which is once you plug in the server, you can do all the rest of the network here. So we really don't need to be concerned about the hardware at that level.
That's a challenge. That's a challenge for me in terms of the marketplace.
Well, I think about I do a lot of airports where they segment services. So you're talking about airlines that want their own VRFs. You're talking about TSA wants their own VRFs. I'm just wondering how we take that approach. I mean, I understand the concept of VXLAN gives us layer 2 adjacencies. Mm-hmm. But a VRF creates an ultra-secure container with your own routing tables, everything else associated with it.
Those containers different, right?
Yes, so we can do it this way. I'm going to go back a couple slides here. We can do it exactly this way. This can be my tenant 1, tenant 2, completely isolated.
I got you. Okay.
See?
Yeah.
Yes. So we have large customers that they have very secure requirements. Like if I'm a provider, let's say I have a hosting service for all of you, my customers. You don't want your data to be seen by anybody else, period. So we have the routing, the switching, the networking. You can completely isolate that, the multi-tenancy.
Gotcha.
You'll talk about it a little more? Yes. And think about this. You did that with the same hardware capacity that you did that. It's like, I don't have to go and buy new hardware for a new customer that just came in. No, I'm just going to create a new environment for them. Okay? So NSX everywhere. Let's touch a little bit on security. You guys live with this all the time. 3 months, the average number of months an attacker sits on your network. That's scary. I mean, if it was your house and you know somebody's living in the basement for that long, you wouldn't like that, right? And they're watching, they're waiting to get that data out. $3.8 million the average cost of data breach. I have talked to customers that they were breached. 5 million plus, right? Just to remediate, and you better do it right from that point. Stolen credentials, number 1. I'm sure all our data is out there by now with the number of attacks and hacks that happen. It's a reality, right? Look at this one, number of security products in an environment, 75. Has anybody been to like Black Hat or one of those security conferences? You go on the show floor is like maybe hundreds of vendors, right? Oh, I can do all this, I can protect you, you trust me, right? Everybody will say the same. It's like, really? Look where we are. I got this data from Information is Beautiful. Data breaches and hacks, 30,000 records or more. This is the last data they had from April. It's huge. It's huge, right? You're talking about millions. 1.6, I'm sure it's there. A lot of hacks happen with a lot of numbers. If you scroll down, this is just a capture. If you scroll down, we all remember Target and Home Depot a few years ago. They're small compared to this. That's scary to me. And you know what's scary? We're so used to that. We hear in the news, I don't have time to read that, right? It happens all the time. And guess what? It's fun when you read it on the news until it's your neck on the line, right? That's not fun. It's like, I need to protect that. Maybe it's too late. So it's a reality, right? So go and look at this. You get to see a lot of these numbers. So the reality, the way we're protecting this, we put a super powerful firewall at the perimeter, right? That's the internet, I'm fine. Well, no, because each one of these VMs can be compromised. These are all VMs, you're my low priority. No. Mike is a system that hasn't been patched. It's a low priority system for me. Sorry, Mike. But guess what? That's going to be a target, right? If I'm a hacker, I found this server, this VM, now I'm sitting there. And I'm going to be sitting there for weeks, and I have this lateral movement. If these are two different VLANs in here, I can move from VM to VM and start seeing what you guys are doing. Take the data and all that. So that's bad news, right? They have free access. This east-west traffic that we want to protect. And your firewall, super powerful firewall, is not seeing any of that. Okay? Most of our customers, we used to ask them, what's your guess? How much of your traffic is inside the data center, the east-west traffic? How much would you guess?
90%.
90%, beautiful, yes. It used to be before, maybe 70. Later it's like, maybe 80. We haven't seen a single customer with less than 90% east-west traffic. And of course, the obvious question is like, I just spent millions on that firewall. They're not seeing 90% of my traffic. That's not good, right? So what if you could put a firewall at every VM? Yeah, everybody says, of course I want that, right? We can certainly do that once you do it in software, right? We're going to create policies for every VM. I dictate what every VM can do that, as opposed to doing it at a hardware level. So in this case, I have a PCI scope. Maybe these 3 VMs are part of the PCI scope. Name it whatever you want, application X. I want to protect those VMs. I can do that. We have this distributed firewall. You heard me say distributed a couple times, because every server, ESXi server that participates in NSX can do this. Why? Well, you know your VM name. You know what operating system you're running. We have that context of that whole vCenter. I can create a firewall rule that says, if you're my web servers, you're my app servers, I can say web to web deny. And if my tier has 5 VMs today or 50 tomorrow, I don't have to touch anything. I know you're a VM, your name starts with web, whatever it is, you're protected. That sounds pretty good. You know, this dynamic network that is protecting itself, that's a pretty cool story.
Do you see any kind of performance on that?
Performance, we typically see around 3% CPU on your servers to do that, because it's distributed, right? If I have 10 servers today and 20 more, I just added that capacity, distribute that everywhere. CPU typically is not the main resource that is overused in a server, it's memory. Well, maybe after storage, right? But memory, you run out of memory before you run out of CPUs. So think about that for ESXi servers, okay? So in a traditional way, we would create a firewall rule to protect this whole segment. My VLAN, my DMC, all these terms we talked about, these VLAN has to be protected by these firewall rules. And I would define firewall rules based on IP address, my source port, my destination, accept, deny. So I would say from 10.10 to 10.20, allow port 80. And I would do it over and over and over again. That became a nightmare. So how about we put a firewall rule at every VM? We protect them. Now we have the option to move those VMs, just like we did before. I can move it from this data center to that data center. That firewall rule policy is going to follow that VM. That's pretty nice. And I'm not protecting these at a VLAN level. All of these VMs can be sitting on the same VLAN if we want. We don't care. We have context. We know your name. We know the VM's name. Now we can do something about that. So if we wanted to do this, customers say, oh, I can put firewall rules. I can put firewalls everywhere and send all the traffic to my firewall rules. So we have two VMs, blue and green. If they wanted to talk to each other, I would have to go all the way to the firewall and back. Is that okay? No. Hairpinning, you may have heard this term. I go all the way out and back, all the way out. Not very efficient at all. You have heard the zero trust model, I'm pretty sure. I want to reduce my attack surface to that low priority system, period. If there's something that gets compromised on that VM, I can quarantine it, I can shut it down, I can do something, but it didn't spread out. And I didn't have those guys for weeks doing that. So we can do that. With NSX, I have that distributed firewall that allows me to say, from blue to green, allow or block. I can do it right there at the hypervisor. Since that information is distributed, that policy allows me to talk to other VMs in other servers. It's a beautiful thing. We have customers, just to give you some examples. If you open a request to get a firewall rule, the SLA was to get back to you within 9 days. Just to get back to you, not to apply the firewall rule. It's like, Joe, what do you need? You need port 80, 443? Sure, we'll get back to you, right? Put it on the list. And the backlog was weeks. They were like 4 weeks behind. So Joe needs port 443 open on that IP address. I would have guys creating firewall rule after firewall rule. By then, maybe you forgot that you needed that. 4 weeks later, I'm just going to allow everything. Not good, right? When you do it in a dynamic environment, the network is dynamic, it creates that for you. That's the beauty of that. So I can create this segmentation regardless of what those VMs are. In here, you can see different groups, IT, HR, finance, think about tenants, et cetera. And on the right, you see web application database. I can reduce that attack surface regardless of where they are. I can create this multi-tenancy, these environments, very easily. Once again, I have visibility into your VMs. I have context. I can do this. So that's the story behind micro-segmentation. Questions before we move into automation?
I got a question.
Yes, Mike.
So when you talk about the NSX security policy and the firewall stuff, that's a software-based firewall that's actually part of the NSX?
Correct. Yes.
And does that NSX security policy stuff integrate with or also utilize like third-party software firewall products as well?
Yes. I'm going to expand just for the recording. So yes, when you buy NSX, you have the full micro-segmentation. We can do all the way to layer 7, app ID identification. You can do all that as part of NSX. But if you want to go to an external Palo Alto, Checkpoint, Fortinet, et cetera, you can also redirect certain traffic to them. We call that service insertion. So you can say, I'm going to do my micro-segmentation at NSX right away here. But maybe that database traffic, I'm going to send it to Palo Alto or Fortinet for an extra check. So yeah, we can certainly do that.
And one follow-on question.
Sure.
So that overhead you mentioned, the 3%, that's per
server.
Firewall, per VM?
That 3% CPU utilization is per server. Per server. Because I put a new server, I install the NSX modules, then I can do all these things, the networking, the firewall, and all that. But it's per server. Yeah. Yes. Oh, microphone.
Coming forward as function as a service. Sorry about that.
So new business models I've been hearing about from a wide variety of segments is function as a service, where people basically rent you a service and then you send them some pennies. How does that fit into this model?
So I'm going to touch a little bit in another area. So function as a service. If you have heard from AWS Lambda, if you have an Amazon Echo at home, you're using that. Instead of saying, I'm going to dedicate a whole server for this application, provisioning, et cetera, function as a service to say, Alexa, what's the weather today? It goes, runs this function, this little code, my 10, 20 lines of code, whatever it is, runs it, and then it disappears. So it's using that memory, that resource for a little bit, disappears, goes away, right? I'm not dedicating a whole server. So that function as a server is very important because now development teams are realizing, like, I don't want to have this whole server, an EC2 server from AWS running 24 servers. Like, I'm just going to run it as a function. And everything I need is going to be a function that disappears the moment I'm done. So that allows you to do that. Let me extend it into the ESXi environment. So you have heard about containers, I'm sure. Containers, sorry if I'm going too deep, but I really want to explain this. Pierre is happy here. So a VM, we know what a VM is, right? I have a server, I deploy a hypervisor, and I can virtualize. Great. But each VM has its own memory, its own CPU that I allocated. Containers are much more flexible. Containers can be created, destroyed all the time, right? VMs are not the ideal way to do that. A container is perfect for that because a container says, I have my VM, yeah, it may be running Linux, for instance. If I turn that into a containers, I share that kernel space, that memory, into multiple containers. So a container I added, destroyed all the time. So going back to the function as a service, I create that, fire up a container, run the function, goes away. With ESXi, if you went to VMworld, you may have heard about Project Pacific, not the most exciting name, but instead of creating VMs on your ESXi, you create containers. So you start to see where this is going, right? There's a lot of value in that. So I think those worlds are going to merge very soon. Is that a function? Is that a container? I don't care. I want my application to be running my virtualized application, my virtualized hardware, it's there for me. Did that make sense?
Yeah, so
Okay. Okay, great. So I hope you're getting an idea what you can start to do with these things, right? It's not only that your storage is virtualized, you start to do a lot of things that we couldn't do before because these resources are available there for us. Yes, Darren.
So I understand the concept of services, right? So across the fabric, creating services and rules of who can communicate. Does it do anything to protect the data in the back end, MAC addresses, IPs, ways that I'm going to get into the physical hardware and attack that network? Okay.
Do you want to repeat it so they can capture?
So, I mean, I understand the concepts of services, right? So you're creating services in VXLAN and defining the rules of how things are going to traverse, in the software-defined network. But the underlying infrastructure on the switches, the MAC addresses, the IP addresses, those things that when you put things in a single VLAN, that's how I'm going to attack your network. Does it have the ability to segment that down below that?
Not to that level, and I don't think you need it. All it is with VXLAN, we're creating this tunnel between these two servers. VXLAN, we talked about that. All we're adding is a source and a destination. Think about VLAN. VLAN we're encapsulating, right? We're putting a VLAN number. Frame relay used to be encapsulation. VXLAN is doing exactly that. All I'm needing from this communication to happen is your source, destination. All the traffic that I send in here, if I'm using 443 or whatever I'm doing, is completely relevant to the tunnel that you're creating. That's why we don't need that. And makes it very, very important because you can create these overlays environment without having to worry about those things. And that's what we want, right? The network is there for you. You can do all that functionality. I think I'm gonna need the microphone. Unless you have more.
No.
Okay,
Good.
okay.
Thank you.
Pierre?
So at that level, and trying to go back to your question, authentication permissions in regards to entry into that environment is critical. That's not on their purview.
So you can define that below.
Yes. Correct. And that's NIST 800-53, and that's automated permissions.
Yep.
Yeah.
Understood.
Okay. So let's jump a little bit into automation. Now we virtualize the servers, we virtualize the storage, the network, the security. Why don't we make this network dynamic and smart and provide all these benefits that I need from a cloud-like environment? You're the user. You need a new application. Something needs to be provisioned for you, your servers and your storage and your networking and all that. So you open a ticket, right? That's where the fun begins, right? Because all these groups are going to be involved in that. Your networking, your storage, your security. It just goes on and on. Oh, the security guys are on PTO. I need to wait until next week. That's a reality, right? I'm sure you live that all the time. We're like, we can do anything. Nobody's provisioned our network. What can we do? After that, there's a lot of these streams. Everybody has to touch this environment. 8 weeks later, you're ready to go. Oh, guess what? You forgot something. I need an extra port to be open. Oh, the firewall guys will get back to you in 9 days. Put your name on the queue, right? That's the reality. Maybe, yes. So if we, instead of doing that, how about we automate this? IT can create this platform that says, you as a user go to the portal, you need this new environment. What size do you want? The t-shirt size? Magic happens. The customer that I was talking about, going from 8 weeks to 22 minutes, that's how long it would take them. Like, well, I can go have a cup of coffee in 22 minutes and come back, everything's there. And I don't have to call IT and wait. That network is there for you. You're virtualizing, you're automating this. And that extends to the security, right? That security is already there because I know the moment I deploy a VM, I'm going to call it web. Going back to the example we had before, the security team already approved the firewall rules for those VMs. I'm fine, right? So automation is really one of the main benefits. I wish I had more automation, but I think by now you understand. Once you virtualize, you're doing it in software, you can do a lot more than being tied to a physical device. So just coming back to this, we talked about the compute, server virtualization, HCI, it's simplifying your storage operations, of course. Network and security, we can automate that as well. And then we can manage all that with the same management framework. Security is everywhere, right? I put it at the bottom, but you guys live this. Security has to be there everywhere. So when we do that, remember we talked about the 3 main things we care about. Business agility was one, right? I need to deploy these things very quickly. Now you start to get the benefits from that. I can scale. I have this cloud-like functionality. I can do that. I want to go to a cloud today. I like AWS today. Maybe I like Azure from Microsoft tomorrow. I can go back and forth. I can do that. And the idea is obviously to remember number 2 or 3 was reduce cost. 2, there you go. So we want to reduce cost. We can do that. We're maximizing the security. This network is very dynamic, is very smart. It's doing all these things for us once we do it in that fashion. So where do we start? That's Darren. Getting ready for the push-ups, I'm sure. It's a big world, right? There's a lot of resources, a lot of things we hear in the industry. Hopefully these give you an idea what you can do. You know, there's a lot more to read, a lot more to learn. I brought a couple books. There are still a few in the back. Micro-segmentation and network virtualization for dummies. They're actually good. There's a lot of good content, easy to digest. Maureen is going to read that on the plane, so she promised. If you don't have one, feel free to grab some of those. But there's a couple more resources that you may consider. I'm just going to touch on the last one, hands-on labs, HOL, we call them. Has anybody done any labs from VMware? Awesome, great. They are free for anybody in the whole world, 24/7. You just log in with your Gmail password, whatever it is. You have full environments. If you want to play with vSAN today, I'm just going to go play vSAN or NSX or ESX. You have about 9 hours to play with a full working environment. You have, you know, the football game is getting a little boring there for Joe. Just go play NSX. Why not? Wonderful resources. So keep that in mind. If you have a little extra time, you want to learn more about these virtualization technologies, that's an amazing resource. Okay. With that, I'll open it again for questions, but I think you have been great. Thank you for all your feedback. It helps me too. So it's a big world. And don't forget, 2:45, we have a very interesting session. Yeah. Yes. Any more questions, comments for anyone? No? Wonderful. So take all the books, please. I don't want to take them home. So thank you for your time, everyone. Thanks. Thank you.